has a very low possibility of occurring. And you'll see that we can actually convert between the two. And we're actually going to use Desmos, that CDF, that cumulative probability thing that I said to uncheck. We can actually use that. But again, it's still good to know how to go back and forth between the standard normal distribution. You know, you don't want the technology doing all the work for you, so to say. Make sure I'm recording. Okay. All right. But again, we can go back and forth using this. We can calculate the z-score. So for an example, let's suppose, again, we're in that case where, although I think the numbers here are slightly different, you have a test, right? The scores are, you know, it's out of 15. The scores are normally distributed with a mean of 8 and a standard deviation of 2. Let's just say we're doing that. So let's find some z-scores. So let's say a student got a 5 on this test. What would the student's z-score be for that? That's why I meant to say z-score here. Well, you know, we have the data value, right? That's our 5. The mean of this is 8. The standard deviation is 2. So we're using this formula here. And it should be z-score, not the student's score. It should be z-score. We fix that. But again, we're using that formula there, right? What we get is, we get our z-score is 5 minus 8. You know, again, the data value minus the mean over the standard deviation. And that's negative 3 over 2, which is negative 1.5. So this data value 5 would correspond to negative 1.5 on the standard normal distribution curve. Excuse me, in the standard normal distribution. You can think of like a data value corresponding to a z-score through this formula. And that's essentially what we're doing here. And notice that since this is negative, this is less than the mean. And since it's negative 1.5, it's about 1.5 standard deviations from the mean. Less than the mean. So 5 is about 1.5 standard deviations from the mean of 8. Now, since it's about negative 1.5, if you went back to the empirical rule as here, you know, it is possible that score, so it's not unlikely. If it was, say, negative 3.5 instead, then it would be a score that's unlikely. Okay, so let's actually, sorry, I pressed the wrong button, but let's keep going. And in the next example here, we can actually go the other way. In other words, if we know the z-score or standard score, that's what the z-scores are also called, we can actually get the corresponding data value. So let me say it again. If somehow we knew the z-score, so a certain student, we know their z-score or standard score, in other words, is 2.5, we can determine the corresponding data value. How do we do that? We're going to use this formula, as I do here. Remember, the mean, that's the mean for the distribution. That's not the standard normal distribution. Standard deviation, same idea. It's the standard deviation for that normal distribution. So let's get our work. So let's do this. So we have z is 2.5. X is our unknown. We have x minus 8 over 2. So we're solving for x. It's an algebra problem now, which makes it fun. It's an algebra problem. And now I just show the steps here, as you can see, right? We want to figure out what x is. How do we do that? Well, we have x minus 8 over 2. You really want to isolate x, right? That's how you solve these problems. I don't remember who's had me for Math 104, but that's what I tried to teach everyone. So excuse me, that's what I taught everyone, right? You isolate x. Although I think in high school they teach that also. So what do? Well, let's get the 2 out of here. And I'm going to do that by multiplying both sides by 2. Remember, multiplication you could do in any order you want. So 2 here is on the right. Here it's on the left, but that's fine. And 2 times 2.5 we know is 5. When you multiply by 2 here, let me get that wonderful pen out. These are going to cancel. And you're left with x minus 8. Okay, so we have x minus 8 is 5. How do we get x? We add 8 to each side. And that's what I'm doing. Because now the 8s are going to cancel. Let me just actually get that pen again. There you are. Right? These cancel. As you can see, we get x all alone left. And on the right, we get 13. So a test score of 13 corresponds to a standard score, a z-score that is, of 2.5. And again, that's a data value that's 2.5 standard deviations to the right of the mean. And if you look at the calculation, that's really what we're doing here, right? 2.5 standard deviations. Well, the standard deviation is 2. So 2.5 would be 4 plus 1, which is 5. Right? So we're taking the mean, which is 8, and we're adding 5 standard deviations to it. We get the data value 13. You know, that's what this calculation is telling us. You know, it's good to think about, what is this calculation telling us? What does it mean? All right. Any questions on this? Okay. Oh, there we go. Okay, so here's what I want everyone to try as well. I know this one's a little involved, but I figured it'd be good for everyone to try this out. You know, I'll give you guys about like 5 minutes, okay? But here you're looking for, you know, it's the same idea, except now we have this word problem. Okay, you have weights of a certain dog breed that are you know, approximately normally distributed, with a mean of 62 pounds, and the standard deviation is 6. So you're going to calculate some z-scores. So, okay. But I want everyone to try that out now. But again, what I'm going to do is I'm going to stop the recording. Okay, we do that.